Hey everybody, welcome back. This is CSE 1322, and today I am going to cover lecture number 17. What we are going to be talking about today is exception handling. But before we get started with all of that, a couple of quick announcements. If you're watching this video and you haven't already taken test 2, don't watch this video right now. Go take test 2. There's nothing on this video that is in test 2, so this is just going to add confusion to you, so make sure you do test 2 before you do this. Other than that, the schedule is here on the screen, and you can see that we are going to do Module 6 this week. This is week number 10, so we are chugging through the semester here. You're 2/3 of the way through. Woohoo! All right, and so today, as I mentioned, we are going to go through exception handling. So what is an exception, and why do we need to handle them? You do this all the time in your real life. Sometimes things don't go the way that you would expect them to go, and you would go off and deal with an exception for that. So, for example, if you are driving down the street in your car and you run out of gas, your car is going to shut off, which is pretty bad. But you don't just die when that happens. What happens is you get out of the car and you walk to a gas station and you buy the little bag of gas, yes, the container of gas, and you bring it back and you put it in the car and away you go again. You handle the exception. It is unusual for that to happen, so it's not something that you are expecting to happen, but you can handle it. And every part of your life is actually like that. You are very good as a human being of handling exceptions because you've gotten used to the idea that things sometimes go wrong. So when you write code, you have to handle all of the possible exceptions that could happen while the code is executing. And some of these circumstances are things that are relatively obvious, where you could have somebody try to go past the end of an array, or you could have somebody, you ask them to type in a number and they type in a letter, which is not great, and so on and so forth. So exception handling allows you to deal with those circumstances, and today that's what we're going to talk about. So the first thing that you need to learn are 3 keywords that you are going to see. We have try, we have catch, and we have finally. All right, so what's happening here is each of these words are used to describe what's going to happen. So if we go back to your car example, you might try driving your car home or to work or wherever it is that you're going that day, and then if you get an exception about running out of gas, you would catch that exception and you would have a routine for refilling the car with gas. And then the finally area is where you deal with things that happen regardless of whether it's succeeded or not, which would include, when you get to work doing whatever work thing you do. All right. So an exception as a general term is an indication that there was a problem. And you want to be able to catch the exceptions, because if you don't catch them, what happens is the program crashes. And honestly, program crashes are really, really bad for the end user. Nobody really wants to see some Java blob of exceptions that get printed out. That's really, really ugly. You, as the coder, are responsible for making sure that even if something bizarre happens, whether it's predictable or not, you should handle all those circumstances. And honestly, as you're writing code, you need to get into the mindset of always thinking about how this user can mess you up. There's a phrase that if you make something foolproof, somebody will make a better fool. And that's probably relatively accurate. When you're thinking about going through and writing code, you always need to have in the back of your mind what possible things could go wrong here. So if you're reading any input from the user, that's probably the most dangerous moment, because the user will give you bizarre things, or they'll not even give them to you. Sometimes their keyboard will produce an error and start throwing random keystrokes in there that they're not even aware of. And your code should be able to handle that. It shouldn't crash just because they did that. Think about like using Microsoft Word or Google Office or something like that. Pretty much no matter what you type into that document, it's not going to crash. I say that confidently nowadays, but if you're used to older versions of Word, I think you know that there were circumstances under which you could crash it. But in general, the goal is to make it so that pretty much anything that could happen is caught. You want your programs to be very fault tolerant. You want them to be looking for these circumstances and dealing with them. And the other thing is that this provides a certain security to your code as well. In general, one of the large ways in which security problems sneak into code is that you're not checking circumstances that the user could give you. So anytime that you're dealing with the user, you really have to be bulletproof. If you ask them for input, you need to really sanitize that the input they gave you is correct and is valid. Please enter your age. Somebody's going to enter in B. Well, what do you do with B? Because it probably doesn't mean anything from an age standpoint. So either you should catch that and say, I'm sorry, B is not a valid age. Could you try again? Or you can perhaps, if it's bad enough, it may be a moment where the program needs to stop. But if it's going to stop, you probably should tell them why it's stopping, and you should handle that in a pretty way, not just allowing it to crash badly. All right. So let's take a look at this example here. So we have class main, and we are taking in two numbers using scanner. And we're asking them to enter in number 1, and we're asking them to enter in number 2. And as you can imagine, this is the very circumstance that I described. You're going to have an idiot who's going to type random things in. But one of the things that they might type in here, we are going to calculate a result, which is number 1, the first thing they entered, divided by number 2. And the very first thing that should pop into your head is, okay, beyond them typing in a letter or something completely crazy, what would cause this to error? Well, I hope you know that you cannot divide by 0. That is not a valid thing. There is no mathematical construct for dividing by 0. So it is flat out going to crash the program if the user types in a 0 here. So that's a circumstance that you need to look out for and you would need to deal with. All right, and so how about here? Let's see what security issues we might have. So this time we're defining an array, and in the array we are reading in user input, and we are putting into, or we're printing out the value of the array at the position that they give us. So we're allowing the user to type in a number, and then we're directly accessing the array at that number. And if alarm bells are not going off in your head right now, they should be, because what if the user was to give us the number 60? Well, the array is defined as 0 to 49. It's an array of 50 elements. So if they type in 60, you are going to directly try to read values out of array at 60 when that does not exist. And that is going to crash your program. This is a security issue because you are not allowed to do that. So you absolutely should not be doing that. It's an array out of bounds error. Okay, so in both of these cases, these are issues. It is not a guarantee that that would always produce an error, and let me be clear about that. It is possible that the user would always be good and enter in numbers between 0 and 49. You could even change your print statement here such that it says, please enter a number between 0 and 49, and then hopefully that would allow the user to not do the wrong thing, but that's not good enough. We need to actually code around the possibility that the user is going to do the wrong thing. So there is a potential for a problem in both of these codes. In the first example, there's a potential for divide by 0, and in the second one, there's a potential that they give us a number that's out of bounds. And each of those will throw these particular exceptions. So inside of Java and C++, C#, there are a bunch of exceptions that it automatically knows how to deal with. One of those exceptions is divide by 0 exception, because that's a very specific thing that can happen. So divide by 0 is one example of a exception that can be thrown. Array index out of bounds is another example. And the wording of each of these exceptions is slightly different between the two languages, but they're basically the same thing, and we're going to see that in just a few moments. Okay, so how do we go about fixing this problem? And the answer to that question is with this syntax, which you may or may not have seen before. The first syntax is the word try, and it takes a set of curly braces, just like a method, and inside of there, you put in whatever problematic code you think you might get. So, for example, you read in the user's input. That by itself is probably not problematic, although you might want to deal with the concept that the user could type in a B and you're going to try and translate that to an integer. So there is actually a problem there as well. But you're going to put in whatever you think is the problematic code in here. If for whatever reason that throws an exception, then the try will fail. If the try fails, it's going to go ahead and look to see, is there a catch for the particular thing that happened? And in this case, we are catching all exceptions, because we're actually taking in the root object for exceptions, which is exceptions. So this will handle anything that the try fails with. There are many different things that the try could fail for. We've already seen two, an index out of bounds and also a divide by zero. There are plenty of others, like you try to read a file and it's not available or it's not there, or so on and so forth. There's lots of reasons why this could happen. You go past the end of the size of a variable. For example, if you have a variable defined as an integer and you try to add a number to it that would exceed the size of the integer, then that's going to produce an error as well. Asterisk. We'll come back to that later in the presentation. All right, so try, then you give it the code that you want it to give a try to. Catch, you can have more than one of these catches, which very specifically says, catch this and do this, catch this and do this. If you think about my silly example of driving your car, there are many things that can go wrong, not just you could run out of fuel. So you could certainly run out of fuel. You could hit a tree. You could hit a deer. You could hit another car. A wheel could deflate and you could have a flat tire. Your check engine light could come on. Your onboard computer could malfunction. There are so many things that can go wrong in a car. So how you deal with each of those would be different, and that's why you could have multiple catches. So you would catch out of fuel as an exception, and you would do one set of things. You would catch engine on fire and do probably a completely different set of things. Going to the gas station and getting gas while your engine's on fire, probably not going to help the situation. So that's why you might have multiple different catches to catch different things. So you would try driving to work, and then you would catch out of gas, you would catch engine on fire, you would catch onboard computer producing error, you would catch engine overheating, or whatever other problems can happen. All right, and then down at the bottom, we have finally. So I kind of want you to think about this like it's an if, then, else. The try is kind of the if, the then is sort of the finally, and then the else is the catch, which is what's happening if something goes wrong. So that's one way to think about it, but more specifically, try, attempt something, catches are there to handle the specific things that happen, and no matter what, this will happen regardless of whether an exception was thrown or not. Okay, so here's a handy dandy little chart that shows you how everything is laid out in Java. So we have mentioned many, many times at the root of all things in Java is an object called object. To be clear, at the root of C#, there is an object called object as well. So both languages have object at the top. In Java, there's an object underneath it that inherits and extends object called throwable, and it has two children, error and exception. Out of memory, stack errors, those are examples of errors. As a matter of fact, there's three of those there. This diagram is a little bit wonky because there's so much on the other side that it all looks like it's on one, but note that these are the only three that actually connect to error. Everything else is connected to exception. So exceptions are circumstances like our array index out of bound, our arithmetic exceptions, which include our divide by zero problems, file not founds, and so on and so forth. Over in C#, the list looks something similar. We have object at the top. This time we have exception. So to be clear, there's an exception in both of these, and it is capitalized in both. And then underneath exception, you have all the various ways that you have exceptions. I think the C# one makes a little bit more sense because it's just nicer laid out, because it's just easier to see what's actually happening there. But I mean, you have all the same things. Index out of range, you have out of memory exceptions, you have file not found, and you have overflow, divide by zero. You have all the things that we have mentioned before. So each of these are the different types of exceptions that can be thrown that you might need to catch. All right. So when a problem occurs in a try block, an exception is thrown, and that is a terminology that you need to get used to. And the reason that they use that terminology is because it is meant to be a very visceral thing. When an exception happens, it is going to stop the execution of that module wherever you are, and it is going to immediately go to the catch if there is one. So the method does not keep going, it just stops right there and then at the moment that the exception is thrown. And There are different ways in which an exception can be thrown. You can choose to throw it yourself if you have a circumstance where you want to throw an error, or there are circumstances that you might run into in your code which will automatically throw an error for you, such as you tried to divide by 0. So we'll see examples of both of those. But in all cases, an exception is thrown, and then it's up to you to catch it. At the moment that the exception is thrown, the execution of that method or that class or wherever we happen to be stops, and it immediately goes and deals with the exception. If there is no try block around it and an exception is thrown, the execution of the entire program is aborted, and at that point you get an error on the screen. If there is a try and catch, then it will attempt to do the catches to see which one is appropriate. If there's no appropriate one, then it will eventually just go to the original solution of failing. So as I mentioned, if your problem does not occur, then the exception will not be thrown, the catch blocks will not be executed, but it will move on to the finally if there is a finally either way. All right, so to be clear, exceptions do not have to happen. They may happen. You should always code for them so that you're looking for circumstances where users could mess with you or something in your program could get out of range. You could exceed an integer, you could try to go past the end of an array, etc., etc. Those are things you need to start learning to code for, and you should be dealing with them with tries and catches. Okay, so let's talk about the catch block. There are a couple of rules. If you have a try, you must have a catch, because there's no reason to put a try in there unless you're going to give catch blocks. So the very moment you decide you're going to go down error handling or exception handling, that is a circumstance where you need to have at least one catch. As I mentioned, you can have more than one catch. And in that case, it is going to execute the catch block that matches the first thing that is your the first exception that is thrown. So if I go back to this little diagram over here, and I see, let's imagine a divide by 0 exception, I could have a catch block for divide by 0, and I could have a catch for arithmetic exception, and I could have a catch for system exception, and a catch for exception. All of those could be separate catches. If that's true, then it's going to go to the first one that matches. So the order in which I wrote the catches would actually matter here, because if I had a catch for exception first, that's the one that's going to fire, because exception is a parent and a divide by 0 is an example of an exception. So therefore, the catch block trying to catch exceptions will fire. If, however, I put divide by 0 first and then put arithmetic exception next and then put system exception and then exception, then the one that will actually fire is the divide by 0. Because this is a class hierarchy. Just like everything else that we have dealt with in all of the different languages, this is just a class hierarchy. So it is going to pick the first one that matches. And the first one that matches out of that particular path, assuming it was divide by 0, is all of those. They will all match that because they're in the path. Just like with inheritance, everybody can be an object because object is at the top. So you can absolutely have an object and then create a new monkey on it, because that's perfectly valid. Monkey may be a subclass of animal, which may be a subclass of mammal, which may be a subclass of object. So you can define the type as object and create new monkey, and that's okay. And then later you can change it. That was polymorphism, right? So in this same way, the exceptions are in this same hierarchy, and you can absolutely catch them at any level. So what I'm saying here is you could always just write a catch that looks for exception, and that will catch any kind of exception that happens. The problem is you may want to handle the exceptions differently depending on what they are. Back to my stupid example, the car is out of gas versus the engine is on fire, you probably want two different blocks. If you just have one catch block that is catching exception, then there's no way for you to know what's going on. So what you would actually need is a catch block for out of gas and a catch block for engine on fire. And maybe at the very bottom, you also have a catch block for exception, which will catch everything else that could possibly go wrong with the car. Because maybe you don't want to write a separate catch for 100 separate versions of computer errors that the computer could have. Okay, so I hope that makes sense. So when it tries to look for a catch block, it is going to match the first one that it comes across that matches. So the order is important. You should always put the child classes before the parent classes in the order tree of exceptions. Usually, the generic exception would be the last one that you would use. Okay, so this is how you would write that out using a couple of different examples. So you might have a catch for IO file not found exception, and you might have a catch for exception. So if the try block, which we presume is up here somewhere, which is apparently probably opening a file or something along those lines, if that try block fails, it's first going to see, is the failure that the file was not found? If that's true, then it's going to do whatever code is in here because that's the first catch. If it's not that, so anything else that fails, like perhaps the file system is read-only and therefore it can't change the file that you were trying to get to. It found the file, but when it tried to open it to write to it, it couldn't do it, then that's going to fall into the more generic exception. And the syntax here is you specify the class or the type of the exception, and then you give it an object name just like you would for anything else. So FNFE is a random name, you could have called it Bob, which is now of type file not found exception. And so inside your code, you can interact with that FNFE object to do whatever it is that you want to do with it. Very often, you're simply going to print it out because that FYNE, I'm sorry, I'm putting a Y in there, that FNFE object is going to have a toString method, which will allow you to actually just print it out, and it will tell you what the exception is. So that's what's going on there. All right, as I mentioned, your finally block is your cleanup block, and this is going to happen regardless of whether it caught an exception or didn't even throw an exception. So one example here is that most operating systems prevent more than one person from trying to write to the same file at the same moment. You have probably run into this. If you try to open Word twice on the same document, you're going to get an error from one of them saying that it's read-only or something along those lines. And that's because both systems cannot have write access to the file at the same moment. So after you open a file, before your program exits or before your method exits that was doing something to the file, it's always important that you close the file back up again. I know we haven't covered file operations. That's actually going to be, I think, next week's lecture. But when you open a file, it's open until you close it. And when you're done with it, you're supposed to close it. So if you have a try where you're reading in user input and trying to write it into the file, and that could stop happening, then at the end, you might want a finally block that closes the file either way. Regardless of whether you succeeded or not, you should close it and make sure that it got closed before the world, before you move on to whatever your next method is. All right, and then the last thing I should mention here is that finally blocks can't see variables that are declared in the try or catch blocks. So again, much like with your if statements, if you declare a variable inside an if statement, you can't see it outside of that if statement, right? Because it's outside of the scope. So you have to be careful that if you're going to do that, you would need to declare it before the try catch block. Okay, so this is just giving you the syntax again. So we have a try. You may have as many catches as you might want, and then you would have a finally that specifies what it is. The try does not take parameters, the finally does not take parameters, but the catch does take a parameter of the type of exception that you want to deal with. Okay, so general kind of rules for life. Yes, you need to get in the habit of looking for everything that the user can do wrong. But rather than having a separate try catch for every single thing, it's probably better to group them as much as you can. So an example of this is I'm going to ask the user to enter in a string of numbers, and then I'm going to do something with that string of numbers. And I want to catch the circumstance where they give me something that isn't a number. I want to catch the circumstance that they give me too many. I want to catch something else. I don't know. The right answer is to wrap that entire section where you're reading everything in once in a try, and then deal with all the possible things that can go wrong in multiple catches. That's a lot more readable than saying, scanner and then trying to read in one line and then having a try catch for that, and then 2 lines later trying to read in another line and having a try catch for that, because you're going to be duplicating the code over and over again, especially in the catch area. So what you want to do is you want to have And you may have multiple in your file. We're not saying you can only have one try catch or anything like that, but you want to narrow it down to the minimum number that you can get away with. So have one big try catch around any time that you're dealing with user input or math where you could possibly produce errors because of invalid inputs and stuff like that. All right. So inside of a method, you can also choose to throw an exception. Now, what does that mean exactly? Well, you might have a circumstance that isn't something that is built into the language, like a divide by 0, but maybe there's a reason logically why you don't want to be able to divide by 10 because of your program. So that's not going to automatically be thrown. This is a circumstance where you would throw an exception yourself. So you can throw any of the built-in exceptions, or you can define your own syntax or your own exception. So we're going to look at Java and C# and see how each of those doing them. All right, so let's take a look at this code here. So we have a C# method, and we're not going to actually have a crash here. So let's take a look at what's going on. Up here in our do stuff, I'm going to attempt to throw new exception, and I'm going to pass it a string CSE 1321 for some strange reason, but sure, we'll go with that. All right, so we're going to do stuff, and when do stuff is called, all that do stuff is going to do is throw an exception. So now before I call my do stuff, I'm going to need to wrap that in a try, because if the method could potentially produce an error or an exception, then I need to actually catch that exception, so I would need to use a try catch. So what's written here is try, do stuff, catch an exception, and print out this particular message. So let's trace this and see what's going to happen. So we're going to begin with our main method, and we're going to go into a try block, and we're going to do stuff. So at this point, we're going to go up to do stuff in the stack. We're going to create a new thing, and immediately it's going to throw an exception. The moment that any exception is thrown, execution stops in that method. So to be clear, nothing that was written below this, if there were anything here inside of the do stuff method, would ever execute. The moment that exception was thrown, we are done, and we are coming all the way back to the point where we were when we called it. That is going to go to the try, and the try realizes an exception has been thrown. So it is also never going to run this line, because the remainder of the code in the try block is also ignored. Once that exception happens, we are done here, and we are moving on looking for a catch to catch the error that has happened. So the exception that has happened. I'm sorry, I am saying error sometimes, and I really do mean to say exception. So there is a distinction between the two. All right, so an exception here happened, and in this case, we are catching all exceptions because we are using the root object exception, the one that is just below object, or it's below throwable in Java, but it's right at the top. So we're catching the exception, we're calling it E, and inside of here we have a print statement that prints out exception thrown and then E.message, which is the message that we got. The message is this, which is CSE 1321. So as it says, that will print out exception thrown CSE 1321. Since we have successfully caught it, we are not going to look at any more catch blocks. Even if there were any more, none of them will take effect. It will only match one catch block. So even if there had been another catch that was very specific about, some other type of exception, it would never happen. The very first one that matches of the catches is the one that's going to fire. So we're going to do this code, and then we are going to move on to finally. Regardless of whether this exception happened or not, this final block is going to happen. So it's going to print that out no matter what. So hopefully that makes sense on the order of the way things work. You are going to do the try. The moment that an exception happens, it's going to stop execution, go look for an appropriate catch, and then no matter what, it's going to do whatever is in finally. All right. This one is another example, and this is not a good example. This one is actually going to crash. And so something that you can't do is you can't have an exception thrown that you are not catching. So up here, we are throwing an exception, but there's nothing trying to catch it. So the moment the exception happens, the program is going to terminate with an error because you didn't catch it. So it's very important that you understand when you're dealing with exceptions, whether they are your own exceptions that you're creating or whether they're the built-in exceptions of the language, once you start dealing with them, you need to catch all of them. And as a matter of fact, as we're going to see later, there are some circumstances where it won't even let you compile unless you try to catch them. I think you actually ran into that when you were dealing with some of the Java FX stuff. Okay, so the throw keyword works the same as C#. In Java, you also have the throws keyword. All right, so let me be clear here. There's a difference between Java and C# in this case. Both of you use the throw keyword. So both of you are going to say throw exception blah if you have an exception that you're wanting to happen. In Java, and only in Java, this does not apply to the C# people, there is a throws keyword which you're going to put at the end of a method to say what it is allowed to throw. So it states what kinds of exceptions it may throw. And there can be more than one of them, and they can be separated by comma. It is very important that you understand for Java that there is a difference between throw and throws, very specifically because this is one of those lovely questions people like to ask you in an interview. So let's review again. Throw means you have a specific problem and right now you would like to throw an exception. Throws is a list of all possible exceptions a specific method may throw. All right? Let's take a look at another example. So again, this is Java code. So public static void do stuff throws exception. So in here we are throwing new exception CSE 1321. And then down here we have our catch and our try and our finally, just the same as we had before. So this is the syntax in Java. You specify that you want it to be allowed to throw, it throws exception. All right. Here's an example where we are going to get a compile time error. So here, because we specified that this method is capable of throwing an exception, which we did not do in the earlier example, the compiler is actually no longer going to be happy because you did not try and catch. The moment you declare that it is possible that I could throw exception, all of a sudden you must wrap the call to that method in try catch always. You will not be allowed to call the method without try catch. And the error that you're going to get from the compiler is actually pretty simple. It's going to say this method can throw exception and you didn't catch it. You must enclose it in a try catch loop or something along a throw catch statement. So there you go. Okay, this is sort of an aside. But let's talk about this because this is also one of those questions where you're going to run into in an interview. There are three words that sound awfully alike, and they actually have completely different meanings, so it's important that you understand the difference between all three of these. So the first word we're going to talk about is final, and hopefully you remember that that's effectively declaring a constant. So if you put final on front of something, so you might say final int x equals 17, then x is set to 17 and it can never be changed. That is what final means. Finally is what we just talked about. At the end of exception handling, it's the thing that happens regardless of whether the try catch happened or not. And then finalize is a destructor for an object. And I don't think we've talked about these before, but I'll briefly explain what a destructor is. We have certainly talked about constructors. So when you say let's imagine you have class A that's defined as a public class. And then down in your main code, you might say A space my A gets new A, and that's how you instantiate a class. The moment that you do that, the constructor for A is called, and we've covered that many, many times. The constructor might set up some variables or it might initialize some stuff. That's what a constructor does. But likewise, there's a moment where you're done with A, where you're no longer going to be using A and it is no longer going to be around. We know that the garbage collector is going to come along and clean it up for you, but there may be things that you want to happen before the garbage collector gets there. So for example, going back to our example about files, if you had opened a file, it may be that you want to write some last stuff into the file and close it just before that object is destroyed. And so a destructor, which is the finalize method, is used in order to clean up when an object is about to be cleaned up by the garbage collector effectively, or when you specifically get rid of the object, when you specifically end the object. So final is effectively a constant. It's a variable that cannot be changed. Finally is a method that is, or it is a section of code that is called regardless of whether a try catch happened or not. And finalize is a destructor in an object. They all sound very alike, but they are quite different concepts. So again, just an aside for interview. And again, these are all Java specific. Okay, you might have reason to need to create your own exceptions. And before I go down that path, I'm going to start looking at a little bit of code just so that we can talk a little bit about how things are working. So before I sat down to record this interview, I went ahead and wrote a very simple program. So it's here in Java and in C Sharp, and both versions are going to be here. They both do exactly the same thing and they are coded the same. I'll interchangeably go back and forth between them, and I will eventually add the appropriate things to both. So in both cases, we have our main, and what it's calling is read numbers, and then it's calculating an average in an array, and it's printing out the average. So very simple. All right, so read numbers, in both cases, this is the Java version, and read numbers in the C# version, they are both doing the same thing. We're setting an input number to 0, we're setting I to 0, and we're saying while the input number is not -1, print out, enter a number, -1 to quit. We're reading in the line, converting it to an integer, and if the number is not -1, we're sticking it into an array at position I, putting in the thing we just read in, and we're incrementing I and current entries. All right? And then for our print, our array average, we are simply going through the array, and we're going from 0 to max size, and we are summing all of the, that is not supposed to be max size, that's supposed to be current entries. I think I got that correct in Java. Let's validate that. Max size. Yeah. It actually would have worked either way, but okay, whatever. All right, so we're doing a loop, and we're pulling out all of the entries from the array at each of those positions that we're looping over and adding them to our sum, which we initially start at 0, and then we are calculating our sum divided by the number of entries, and that is, of course, our average, which we then return. Okay, so to be clear, both of these are using an array. It's defined up here at the top. Static int num array equals new int max size, and up here it is static int, oh goodness, static int num array equals new int max size. Are they the same syntax? No, they're not. The one that's different is where the square brackets end up. All right, so max size is set to 5 in both of these cases, so in both cases it's setting an array of 5. All right, so let's actually run this guy. I'm going to run the C# version. They both run the same. And I'm going to type in, it's going to ask me for a number. Enter a number, -1 to quit. So I'm going to type in 4, and then I'm going to type in 6, and then I'm going to type in 8, and then I'm going to type in -1, and it says the average of those numbers is 6. 4, 6, and 8 does indeed average to 6. Yay, works. And just to prove a point, over here in Java, oh, I don't know why I stopped that. That was silly. I'm going to enter in the same exact numbers, 4, 6, and 8, and then a -1 to tell it that I'm done. And it says the average is 6. So life is good. Both of these programs are doing exactly what I would expect them to do. But hopefully you are thinking somewhere in the back of your head, there are a couple of things that could go very, very wrong here. So the first thing is that I'm writing all of those entries into an array which has a max size of 5. So just for giggles, I'm going to run this guy again. This is the C# version, and I'm going to enter in 6 numbers. 2, 2, 2, 2, 2, 2. Unhandled exception. System index out of range exception index was outside the bounds of the array. Why? Because I read in 6 numbers. The first 5 went into 0 to 4 of the array, but when it tried to insert the next one, it was trying to insert it into the array at position 5, which is not valid because the array goes from 0 to 4 because that's what I specified. Likewise, over here in Java, I'm going to get a similar error. So I'm going to do the same thing. I'm going to type in 2222222, and, or maybe I'm not, because maybe it's going to take a moment. So how you doing? Okay, here we go. 2222222. exception in thread main java.lang.array out of bounds exception index 5 out of bounds for length 5 because it goes from 0 to 4. So they both threw exceptions, as you can see. C# very specifically said unhandled exception. I think it now wants you to go sit in a corner and think about what you have done. And over here, it doesn't very specifically say that it was unhandled, but it is still unhandled because there was nothing in there. So that is one problem with this code. The second problem with this code is I calculate the average based on the number of entries that are in there, which the number of entries is initially set to 0. So I think you can see where we're going here. I'm going to hit run on both of these programs. And over here, I'm going to type -1, which means I didn't put any numbers into the array. So I'm asking it to sum up the array, which is going to be 0, and divide by the number of entries, which is going to be 0. And bada bing, I'm going to get an unhandled exception, divide by 0 exception. And the same thing is going to happen over here in Java. Exception, arithmetic exception, divide by 0. Okay, so I have hereby given you a block of code which is very, very flawed. We are now going to fix it. How are we going to fix it? Well, let's start with the divide by 0 error. So what we're going to do is the problem line is here. Up until this moment, nothing could go wrong, right? Okay, well, we could be getting bad input from the user, but as far as calculating the average is concerned, the moment where it can go wrong for my divide by 0 is here, and that's possibly because current entries could be 0. So the way that we're going to handle this is we're going to say try, and then we are going to wrap this method, or this line of code, in our try block. The moment that I have a try block, I must have a catch block. So I'm going to catch exception E. All right. So now that I've caught it, what is it that I wanted to do again? Well, so let's imagine that I would define in my world that I'm always going to return 0, because that probably is what they meant, because the average of all is nothing is nothing. So I'm going to arbitrarily decide that the average of nothing, is 0, very specifically. So I'm going to say answer to return equals 0. And then I'm just going to tell them what happened. So I'm going to do, what language am I in? Java, system.out.println. And I'm going to say, all right, probably should be nicer to your users than that, but okay, whatever. Their fault. They shouldn't have done it. All right, so we're going to go over here, and we're going to run this again. And I'm going to do the exact same thing, which will cause the error. Okay, so this is much prettier. I didn't get a big, hideous block of text that told me to go sit in a corner, and I didn't get this. Which, if any part of that looks user-friendly to you, then you are not a nice person. Users should never see something like that. There are memory addresses in here. There is all kinds of information about what methods were being called. All of that going to the user is at worst ugly, at best it's ugly. At worst, you could be leaking all kinds of information about the internals of your code to the user, which could actually be a security problem, because it's possible that at the moment that exception was thrown, you are in the middle of connecting to a database with this string, with this username and this password, which could very well get printed out on the screen to the end user. So they could see something that you never intended them to see. So this is another reason why it's always important to catch your errors. Okay, so clearly that's much nicer. Let's do the same work over here. So I'm calculating this the same way, and this is C#. Nothing actually changes. I'm going to do all the same exact lines that I did in Java, and then I'm going to eat my words and tell you what actually did change. Catch exception E, and this time what we're doing is answer to return equals 0 and console.writeLine. What did I write? I wrote something very clever, I'm sure. Here, I will just save myself and you from having to watch me attempt to type, and I will copy and paste between the two windows, and we're going to compile that again, and I'm going to do -1. And the average of nothing is 0 because I said so. Average of numbers is 0. Okay, great. So I did catch that. You will note up here in C sharp, and I don't think I got this in Java, did I? C sharp is pointing out that I declared a variable e and I never used it. So just to show you what e is, I'm going to put a plus e at the end of my string that I'm printing out, and I'm going to do the same thing over in Java. Right there, plus e. And we're going to run that guy. Okay, so over here, I'm no longer getting the error because I'm actually using the e. I'm going to put in the -1. And now my lovely print statement of the average of nothing is 0 because I said so ends with the actual details of the exception that was caught, because that's what you got here. So I want you to think about that for just a moment. Not sit in the corner and think about it. I just want you to think about it. So the exception that was thrown here was a divide by 0 error. That was true regardless of whether I caught it or not. If I didn't catch it, if I didn't have the try and the catch, then what C# does and what Java does is they just throw up that onto the console. When you catch it, you can decide what you want to do with it, and you can look at it, you can decide if that's what you want to do. But you do have access to the message. It's right there inside of the method that are the exception that came in. And the same thing happens over here. I will now see the details of the error, and there it is, Java language arithmetic error divide by 0. Okay, so you have access to that variable. You can do with it as you please. Okay, so just to prove what happens if you have different types of exceptions, I'm going to add another catch block in here. What language I'm in? Java. So in Java, this is a arithmetic exception, which I cannot spell, so there you go. Thank you for code completing that. Arithmetic exception, and I'll call this Bob, just so that you can see that there's nothing magical about that. And then in here, I'm going to do answer to return equals 1, and I'm going to okay, and I'm going. So now to be clear, what's happened here is I have added in a second catch for this try. You must have at least one, but you are allowed to have more than one. Just to keep the C# folks up to speed here, I'm going to do the same on this side. So in C#, I'm going to add catch, and this one is called divide by 0 exception Bob, I think. Okay, so compiling that guy, and over here compiling this guy. All right, compilation error, one warning. The variable Bob is declared but is never used. That's fine. I'm getting weird characters on the screen again for some reason, but that's okay. All right, so I'm now going to force the error, and this time I get oops, I did it again. And I should get the same thing in Java. Oops, I did it again. All right, so to be clear, the reason that I did this was to show you that the order of the catches matters. So I caught the very specific exception, arithmetic exception, and in there I typed out, oops, I did it again, and I set the value to be 1, which is what eventually got returned. So when the error was thrown, the error that was thrown was divide by 0 error, which is an arithmetic exception. Am I saying that wrong because it sounds weird in my head? Arithmetic exception? Yeah, I think that sounds better. Okay, we'll go with arithmetic exception. So the arithmetic exception was thrown at the moment that I did a divide by 0. When it tried to match a catch, it starts looking at this one and it decides, does that match? Since an arithmetic exception is an arithmetic exception, this one matched perfectly, therefore it did that, and it stopped. It did not keep going to see if there were any others. So why did this work before when I just had exception? Well, because an arithmetic exception is a child of exception. So this also matches, but it will only do the first one. So what I'm saying here is I am getting an oops, I did it again instead of the average of nothing is 0 because I said so, specifically because the type of exception that's being thrown is being handled first up here, not down here. It does them in order, and the first one that matches is the one that it takes. And just to prove that the arithmetic is a child, I'm going to go back to that happy little tree slide. Or I'm never going to find the happy little tree slide. There it is. And you can see arithmetic exception, which is what I'm catching at the moment, is a child of runtime exception, which is a child of exception. All right? And in C#, what I looked for was divide by 0, which is a child of arithmetic exception, which is a child of system exception, which is a child of exception. So same thing happens there. So I need you to be clear that there can be more than one catch, and the first one that happens that matches is the one it's going to use. Even if there is a more specific one down below, the first one that matches is the one that will happen. So just be careful about the order that you write them, and you generally want to put the most specific one at the top and then work your way down to more general ones down below. Okay, so hopefully that makes sense for catching built-in exceptions, because that's what we've been talking about. So let's go down to defining our own exceptions, because maybe I want to know that my car is on fire. Where were we? We were somewhere down here, throwing exceptions in Java. And that was that. Interview advice, we covered that. You would think I would have bookmarked where we were, but I did not, so here we are, creating your own expressions. Cool. All right, so the example that they give here is you might have car cannot start as an exception that can get thrown by your code, because that is very specific to your logic. It's not something that the computer is going to automatically call, because it doesn't know car does not start. That's not something that it actually understands. So these are examples where you in your code want to have something specifically fire an exception so that you can handle it if that exception happens. These are going to be more logical kinds of things. In order to do that, you're going to define a class, and then it's going to have a default constructor and an overloaded constructor that perhaps takes in a string. But the exception is going to inherit from exception. So car not started is going to inherit from exception, or perhaps one of exception's children, depending on what you're going to do. So here we have, this is obviously Java, so insufficient funds exception. Okay, that makes good sense. You're doing something with a bank and they're trying to withdraw money out of an account that doesn't have enough money in it. Given COVID, I'm sure we're all very familiar with this problem. All right, so an insufficient funds exception is going to extend exceptions, and then you're going to have a constructor and another constructor that takes in a message. Once you have done that, this is the same exact syntax in C#, except obviously the word extends gets replaced by a colon. And in this case, you are calling super. In Java, in this case, you are calling the base. So by passing a message to exception, you are asking it to print out that message or to have it as the reason for its error. Okay, so let's go ahead and do this in our code before we talked about the unchecked and checked. So the other problem that I had that I wanted to deal with in my wonderful little averaging program here, which apparently is the worst written code ever, is that I want to be able to detect if they do something dumb like enter in too many numbers. So again, I am defining my array as being of size 5, and if they enter in, it doesn't matter what they enter, obviously they can type whatever they want, eventually I'm going to get an index out of bounds. And likewise over here, what is going on with this window? It's being weird. Is it running? I don't know if it's running or not. We're going to stop it. Terminated. Excellent. All right. Boom, we get an error. Okay, to be fair, we got an error because I typed in E. What I meant to type in was a number. Oh, goodness. Wow. Okay, something is causing random garbage to be inserted in here. I have noticed that if you have Replit open on two different machines at the same moment, or you have two different Replits open and you're working in C#, you get this weirdness where random characters appear on the screen sometimes. I do not understand it, but I need two windows because I want to be able to show you back and forth. So anyway, I think you get the idea of what I'm trying to show, and we're just going to talk about the Java one because it actually worked and I didn't get the other weird exception. So what we're trying to deal with is this circumstance where they've entered in too many errors. So what type of exception should, where they entered in too many numbers is what I was trying to say. So what type of exception should that be? In my head, that should be a you entered in too many numbers exception, not a file IO exception or an arithmetic exception, because that's not really what it is. And I don't like the idea of using out of bounds. I'm just going to define my own class for my own exception. So in Java, I'm going to say class, and it's going to bark at me unless I put this in a separate file. So I'm going to call it too many.java. All right, and over here I'm going to have public class too many, which extends exception. All right, and I'm going to put in a constructor, which should probably be public. Too many, and it's not going to have any code. And then I'm going to have too many, which takes in a string. And it is going to call super with the message. Okay. What did I do wrong? It was a capital S, which I think is what I typed first, but I convinced myself otherwise. All right, while it's thinking about that, I'm going to grab that and I'm going to come over to the C# window and I'm going to paste in the same code. Instead of the word extends, I'm going to change that to a colon, and this gets colon base message instead of the body. Clearing the screen and seeing what we get here. It is not happy with something. What are you not happy with? Line 8, public class. That is because there is, I think, supposed to be a semicolon there. Is there? No, that doesn't make any sense. Must have a body because it is not abstract. Too many. Must have a body. Must have a body. Must have a body. Okay. How do we do in Java? Java compiled. Okay. Okay. There needs to be a body. It's like it's telling me what to do and I'm just not listening to it. There we go. Okay, cool. All right, so now we have a new exception called too many. All right, so we are going to go about throwing it when they give us too many numbers. All right, so down in my method where I'm reading in the numbers, I am counting how many they gave me, which is current entries. So let's see, where do I want to do this? Enter in a number, scan it in. If the number is not -1, stick it into the array. Okay, so I clearly need to do it before I stick it into the array. So what I'm going to do is I'm going to say try. What am I doing? I'm not trying to try. I am trying to right. Sorry, my brain turned off for a moment. If I is greater than max size, which is the grand size of everything, then I'm going to throw new exception. It's actually going to be a new too many. Why is there a closed bracket there? That should be there. And it would be nice if I put that on a new line. Okay, so what's happening here is I'm very specifically going out of my way to throw an exception because I have decided that they are not going to be allowed to enter in too many numbers. Now, this is not going to compile. I want you to think for a moment why this is not going to compile. And hopefully it's for the reason that I was thinking about. Yes. So I declared that I'm going to throw this exception down here. But in Java, I never specified that this method is allowed to throw it, which that's not really what the throws does. It specifies that it is going to be thrown. But most specifically, I am never checking down here for that exception. So Java realized straight away that there's a circumstance under which I may throw this exception and it is not being caught. And that's not allowed. If you go off and you define your own exceptions and you throw them, then you better catch them. So it's complaining that I must catch this variable if I'm going to go down this path, or catch this exception if I'm going to go down this path. All right, so try read number. I'm going to try and be consistent with my parentheses or curly braces or whatever they are. And then we're going to catch too many. We'll call it B for no apparent reason. And I'm going to say, I'm not console.writeLine, I'm system.out.println. You have entered too many numbers. Actually, you know what? That's the message that it actually gave me. So I can just do error plus B. Okay, so let's go ahead and give that a try. After all that. Unreported exception too many must be caught or declared to be thrown. Yep, I also never said it throws too many. Am I not in Java? I am in Java. All right, error expected, parentheses. Oh, goodness. Put that before the parentheses. Sorry. We'll get there. What are you doing? Come along, hurry it up. Okay, we're just going to stop. And we're going to run it again. See if it'll actually do it this time. Here we go. Okay, so I'm going to enter in too many numbers. Exception in thread. Array index out of bounds exception. Index 5 is out of bounds. It did not catch my circumstance. Why did it not catch it? Because I said if I is greater than max size, and max size is 5, and I really needed to check if it was greater than 4. There we go. Okay, so it caught it. It threw it. It caught it. You gave me too many numbers. The average of the numbers is 5. All right, so to be clear, I wrote some code, which was an if statement, and in the circumstance that that if statement happens, it is going to throw a new exception. That exception is one that I defined as a class called too many. Class too many extends exception. It has a constructor which takes in a message and it passes the message up to its parent. So when this too many is thrown, so when I say throw this new object, that message gets passed up to exception, and exception knows to be able to print it. So when I do print error, I get back the actual message from up there when I catch it down here. In case you thought that your eyes were going crazy, the screen was getting more red. It's my nightlight turning on. I apologize. Happens automatically at sunset, and apparently the sun is setting. All right, so we have at this point, talked about how to define your own error, your own exception. I never actually did it up in C#, so let me do it up there. We did declare the class, but I never actually used it, so when we were reading in numbers, I needed to check if I is greater than or equal to max size, then I'm going to throw new too many, and same error message, hopefully. I put in that. There is no throws that needs to be added up here because C# doesn't do that, but I will get an error if I try to run this right now because it's going to complain that I'm throwing an error and it's never being caught. It's declared but never used. Did I terminate it? Okay, so it'll actually let me do it, but what's going to error now is that I have an unhandled exception of too many. So I need to handle that exception. And we do that by wrapping the code that could potentially produce the exception in a try block. And we are going to catch. And in this case, it is a too many. And I'm going to console write line error, and B is what I called it here. And life should be good, unless I did something dumb. Life is good. Too many. You enter too many numbers. And then I am getting the rest of the error there, which if I didn't want that, I could just error out what it is that I actually wanted to error out. Okay, so hopefully that makes sense. These codes are here. You guys can pause the video and look at the URLs for both the Java and C#. They are now the completed code, so if you go look at them, they will have all that in here, but you're welcome to take them and fork them and play around with them so that you can catch other types of exceptions. There is one more thing that I need to talk about, which is the distinction between a caught exception and an uncaught exception. So there are two different types in Java. I said caught, didn't I? I apologize, guys. It's been a long day. Unchecked and checked was what I meant to say. So a unchecked exception is one which the compiler cannot check. And that simply means that if you throw an exception, the compiler is never going to know that you could have done that. A checked exception is one that you have to deal with because the compiler is actually going to stop you from doing it. So I think you guys ran into this once when you were dealing with some of the graphics stuff in the GUI class a couple of days ago. There was at least one method that we extended, and I don't remember off the top of my head which one it was, but you can probably go back and look at the video, where at the top I had to add in a try catch, and I think at the time when I was doing that I said to you guys, I'll explain this later. Because a method that I inherited had a throws declaration at the top of it, I must deal with the try catch anytime that I use that method. If I don't put the try catch around it, the compiler will stop me from doing it. This is a checked exception. If it doesn't declare that it's going to throw it, then at that point, I am welcome to deal with it only if I want to deal with it. If I don't deal with it, it will just crash the program and print the data out to the screen. So checked exceptions can be checked by the compiler. That's really the important part here. So once you declare that something is going to, once you declare something throws an exception, you definitely need to actually write a try catch block around it on the other side. So checked and unchecked exceptions. Let's take a look at a couple of quick examples. So this is a circumstance where you have an error. So, or you could possibly have an error. We are calling system.out.print, enter a character, and then we are calling system.in.read. So system.in.read, which is not really something that we have looked at very much. This is a Java-specific way of reading in from the console. If you're not using scanner, it is just going to read in a byte. The downside of system.in.read is that it can throw exceptions. Very specifically, it will throw an IO exception if it's not happy with what you type in. So because of this, this does not compile. I cannot use system.in.read without actually putting a try block around it. because it can throw an error. It's declared in its definition as being able to throw IO exceptions. So if you are looking at the definition of read, it would have read, open paren, close paren, throws IO exception. And because they declared that it throws that, the compiler says, nope, you can't use that unless you actually handle that exception. It is an unresolved compilation problem. All right, and if we look over here, this is a weird example which I stared at earlier, and this doesn't actually produce a divide by zero error, so I'm not really sure why that says division by zero. I think there's a typo in here. I'm not really sure, but either way, let's presume that there's an imaginary divide by zero error here. So the question is this a checked or an unchecked, as I can't remember the word, is this a checked or an unchecked exception? And the answer is, this is unchecked. There is no way for the compiler to know that this could produce a divide by zero error. All right, hopefully that makes some sense. There's one more word that you might want to be aware of, especially if you're in the C# language. In C# there is a word called checked, where you can very specifically force the compiler to look for errors. Let me explain what I mean by that. So if we take this example here, int value equals this big long number. That turns out to be pretty close to the maximum size that you can store in an int. So if I then add 10 to it, that is going to cause an error. However, the error that it's going to cause is it's just going to wrap around, right? Because you remember, if you go past the maximum value of an integer, it will simply just wrap around to a big negative number, because that's how it stores things. In binary, the first digit represents negatives, positives. And there's a big long story there, but the short version is, if you go too far with a number of a specific type, you will wrap all the way around and end up with a very large negative number. This is obviously very surprising, and this code is very clear because you're only doing 2 lines, but it could be that you're adding numbers to a number continuously for a long period of time, and only at the end might you run into this issue. So it's important to be aware of the fact that if you wanted to be able to actually throw an error here, you can, in C#, put the word checked in there. So now what's going to happen is this will actually throw an overflow exception, because it's forcing it to continuously check the size of value, even in runtime, to see if you get past that. So it's a way of forcing the compiler to note that even as it's running, I want you to be able to actually throw the exception. Without the word checked, it will just silently print out this ridiculously large negative number. With the word checked, it throws an exception for you, and at this point you can now actually go off and handle that exception. You're getting an overflow exception. So you could put a try catch block around this and then give the user some useful information about what's going on. Okay, so let's summarize. Today we have talked about exceptions. Exceptions are your way of writing code to catch circumstances that could happen as the code is running. There is the try, catch, and finally blocks that you might need to write, which will try something which could potentially throw an exception, catch, which will catch a specific type of exception and allow you to do code around it, and then finally, which will happen regardless of whether the try succeeded or failed, i.e. whether it threw an exception or did not throw an exception. What happens in finally will happen either way. You can throw exceptions in methods by simply saying throw new exception and then whatever type of exception you want to do. So it will be throw new too many was what I did when I made it in my own class, but you can also simply throw new exception with a capital E, and that will throw a generic exception for you. You can create your own exceptions by inheriting from the existing exception class, and I showed you an example of that. And then we talked about checked versus unchecked in Java and the checked keyword in C#, which are specific. So that allows you to write much better code where you're checking for all these weird things that could potentially go wrong, and I would strongly encourage you to start using all of these. Again, none of this is on test 2, so if you stuck with me for the last hour for some strange reason, go study for test 2, because none of this is on there. And I will see you guys next week. That is all that we are going to have for this module. It is just this one set of slides. So the next video will be posted probably Monday of next week. Hope you guys have a lovely week, and I will talk to you soon.